All right, let's jump right in. Welcome to this explainer on a topic that quite literally makes or breaks a top-tier grade, Cambridge Biology 9700, specifically Section 6.1, Antiparallel Strands and Hydrogen Bonding. We are going straight into the deep end today. Absolutely zero fluff, just the pure examiner-approved strategies you need to completely master this topic. So if you've been just memorizing textbook definitions, hoping for a top-band mark, well, you're in exactly the right place to upgrade your entire approach. 15%. Just let that sink in for a second. That is a massive chunk of your total marks in Paper 2 sitting squarely on how well you understand 6.1, anti-parallel strands, and hydrogen bonding. This isn't just some minor detail you can skim over the night before the exam. This single topic represents a huge grade boundary risk. Mastering this one specific area is, without a doubt, one of the most highly efficient ways to secure a massive advantage for yourself.
But here is the painful reality we've got to face. Are you confusing cause and effect? Because according to Cambridge principal examiners themselves, this is the absolute #1 primary mistake students make in this exact syllabus section. Candidates repeatedly bleed marks because they write down perfectly factual biology that actually answers the question entirely backward. It's a huge confidence shock, right? You get your paper back and you thought you nailed the material. You need a targeted, structured solution to ensure your scientific reasoning flows in the exact direction the mark scheme actually demands.
Okay, moving into Section 1, Core Biology Exam Principles. We really need to step back and look at what examiners actually demand from you. Ordinary revision completely fails here because it focuses purely on recall. The syllabus clearly emphasizes that top-performing students don't just remember facts, they exhibit connected, transferable understanding. Anti-parallel strands and hydrogen bonding isn't just a pretty diagram of DNA you label and move on from. It requires structured analysis. It demands that you establish causal relationships. Remember our cause and effect warning earlier? And it absolutely requires cross-topic integration. Superficial knowledge is entirely useless when you're thrown into a totally unfamiliar context on the exam paper. You have to integrate this knowledge with other syllabus areas. In fact, principal examiner reports consistently highlight that candidates who reference these cross-topic connections achieve significantly higher marks. So the assessment targets 3 distinct skills. Yes, of course, you need knowledge and understanding, but you also need to accurately handle and evaluate information, and you have to demonstrate experimental skills. This assessment framework heavily prioritizes analytical depth over superficial breadth. The examiners are specifically testing whether you can move past just rote memorization and actually step into applied science. Now, in just a moment, I'm going to reveal the ultimate examiner clue that completely changes how you structure your answer. The one thing that instantly elevates a standard response right into the top mark band. But first, you absolutely need the procedural framework that makes that clue obvious. Because honestly, without the framework, the clue is totally useless.
Which brings us to Section 2, the method mark strategy. When you are tackling these complex, multi-step problems in Biology 9700, you are not just being graded on your final conclusion. The examiners actually award marks for the rigorous analytical process itself. This is where evidence-based reasoning becomes your absolute best friend. So here is that standardized sequence you need to follow. First, identify the key elements by deconstructing the question and extracting relevant data from the stimulus materials. Second, select and apply the relevant biological principles. Third, execute your analysis with very clear logical working. Fourth, verify your results. And fifth, present your final answer in the appropriate format using correct, precise terminology. This step-by-step breakdown is exactly how you guarantee you pick up every single available method mark along the way, even if your final calculation or conclusion is slightly off.
Next up, Section 3, Top Principal Examiner Warnings.
So, what are the people who actually grade your papers explicitly warning us about in their official reports? What truly separates a mid-tier paper from a top-tier paper? Well, think of it this way. You have the flawed approach, which is the generic answer. This is where a student reads a question about hydrogen bonding and just repeats textbook facts without any real application. It's safe, sure. It's biologically accurate, yes, but it scores incredibly poorly. Then you have the context-specific answer. This is the top-band, fully examiner-approved approach. Here, every single theoretical point is linked directly to the given scenario. So if the stimulus provides a novel organism or a totally unique cellular environment, your discussion of anti-parallel strands must integrate that exact environment. No exceptions. And hey, don't just take my word for it. Listen to this direct quote straight from the principal examiner report. The classic mistake is providing generic answers not specific to the question context.
Always link every point to the given scenario. It really is that simple. If you memorize only one thing from this entire explainer today, please let it be this. Generic biology gets generic grades. Applied, contextualized biology unlocks the top bands.
Moving right along to Section 4, Critical Analysis and Evaluation. We are really raising the bar here, from basic question answering to the elite data interpretation expected of high-performing candidates. This is where handling and evaluating information really comes into play. The crucial point is knowing exactly how to handle numerical evidence. If you're given data related to 6.1, you might very well be asked to interpret relationships or calculate statistics. You absolutely must know which statistical test to deploy for which situation. The t-test is your go-to for comparing means. Chi-squared is strictly used for categorical data. And correlation tests? Those are used when you're looking for relationships between continuous variables. Selecting the wrong analytical framework instantly caps your grade for that question, no matter how good your math is.
But beyond just running the numbers, top-scoring candidates demonstrate what we call evaluative thinking. Think of this as your mental checklist for evidence quality. When you're looking at a novel scenario involving DNA structure or bonding, you need to question the initial assumptions, consider different perspectives. Crucially, you've got to identify the limitations of the data provided. Are there alternative interpretations for why a strand is behaving a certain way under specific thermal conditions? Justify every single decision you make with hard, factual evidence. Evaluating evidence quality is literally the ultimate key to accessing those very highest mark bands.
And guess what? This exact same structured analytical approach applies directly to your experimental skills and practical work too. If you are designing a practical investigation, you must logically select the appropriate apparatus, follow sequential instructions completely accurately, record your data in highly suitable, well-headed tables, identify any anomalies in your results, and ultimately draw conclusions that are strictly based on the evidence you actually collected, not just what the textbook says should have happened.
And finally, Section 5, Final Strategy and Takeaways.
So we've deconstructed the conceptual requirements, the analytical process, and the specific pitfalls that examiners highlight every single year. To completely solidify your strategy, let's do a rapid recap of the 3 critical mistakes explicitly found in the examiner reports. Number 1, confusing cause and effect. Be incredibly precise about what actually drives a biological mechanism. Number 2, forgetting to check units and terminology. Precision in your notation is totally non-negotiable. And number 3, providing answers not specific to the context given. Like we said, generic answers bleed marks. If you can consciously eliminate these 3 errors from your practice papers starting today, your baseline score is absolutely going to jump.
But wait, hang on a second. We need a hard pivot here. Because everything we literally just covered, this brilliant procedural framework, the statistical tests, the avoidance of generic answers, all of it is completely and utterly useless if you misinterpret the actual exam prompt before you even begin writing. Which leads us to our final and maybe most critical question. Do you actually know the specific command words that dictate your final mark band? Because if you don't know the precise Cambridge-defined difference between explain, describe, and evaluate, you are going to write an absolutely perfect answer to the completely wrong question. It's the hidden cause of so many lost marks for smart students. You must learn this final piece of the puzzle to truly secure your grade. So how well do you actually know your command words?